So good morning. So now discuss continuous for laser actions, conditions for laser actions. So we already discussed the 3 points in previous video. So now move with mechanisms of light emissions. So the Einstein's quantum theory of radiation, determination of Einstein's coefficients A and B. So we know that when light is absorbed by the atoms or molecules, then it goes from the lower energy level to the higher energy level. And during the transition from higher energy level to lower energy level, the light is emitted from the atoms or molecules. So let us consider an atom exposed to photons of energy E2 minus E1, that is equal to h nu. So three distinct process takes place. So first one is absorption, second one is a spontaneous emission, and third one is that stimulated emission. So first one, the absorption. So absorption, an atom in the lower energy level or ground state energy level E1 absorbs the incident photon radiation of energy h nu and goes to the higher energy level or excited state E2. So this process is called as that absorption. See the diagram 1. So if there are many number of atoms in the ground state, then each atom will absorb the energy from the incident photon and goes to the excited state. So then the rate of absorption R12 is proportional to the following factors. So R12 directly proportional to energy density of incident radiation and number of photons in the ground states. So therefore R12 equal to B12 rho V N1. So here B12 is that constant which gives the probability of absorption transition per unit time. So so normally the atoms in the excited state will not stay there for a long time. So rather it comes to the ground state by emitting a photon E equal to h nu. Such as emission takes place one of the following two methods: spontaneous emission, stimulated emission. This is a spontaneous emission. So the atom in the excited state returns to the ground state by emitting a photon of energy E equal to E2 minus E1. See the diagram like this. So spontaneously without any external triggering. So this process is known as the spontaneous emission. Such as in emission is random and it's independent of incident radiation. So if N1 and M2 are the number of atoms in the ground state, E1 and E2 excited state. So then the rate of absorption of emission R21 spontaneous is directly proportional to A21 N2. So here A21 is the constant which gives the probability of spontaneous emission transition per unit time. So next process is that stimulated emission. So the atom in the excited state can also return to the ground state by external triggering induced for photons, thereby emitting a photon of energy equal to the energy of the incident photon, so known as the stimulated emission. So that's a result in the two photons of same energy, phase difference and same directionality. See that photon is incident and then atoms are return back to the excited state to ground state. The rate of stimulated emission is given by R21 stimulated is directly proportional to the number of atoms in the excited state and intensity of the laser beam. So therefore B21 rho V N2. So where B21 is the constant which gives the probability of stimulated emissions transition per unit time. See, in these conditions, absorption, spontaneous emission and stimulated emission, so we know that the atoms in the excited state will not stay for a long time. So rather it comes to a ground state by emitting a photon energy equal to h nu. Such an emission takes place by the, one of the two methods, spontaneous and stimulated emission. So spontaneous means spontaneously without any external triggering. So that is a spontaneous emission. And stimulated emission means the photon, they will be emitting a photon of energy equal to the energy of the incident photon. This is known as the stimulated emissions. So thank you. We discuss in next video.